What is a common theme between the movies Da Vinci Code, Angels and Demons, Indiana Jones series, or National Treasure series? All these and many such movies involve solving secret codes and messages to find a treasure, solve a mystery, or ensure a disguised form of communication so that only the intended recipient receives the message. How does hiding messages or cryptography, as it is popularly called, play a part in blockchain? Let us first look at what is cryptography. We use cryptography on a daily basis even without realizing it. Most of the instant messaging apps like WhatsApp, WeChat use encryption to safeguard the communication between users. While accessing online accounts, email, banking, shopping, etc., we enter a combination of username and password. Password, in effect, is an encrypted form of the unique combination of characters we have chosen. To summarize it in simple terms, cryptography is the method of disguising information to ensure that it is revealed only to the intended recipient. This sequence of concealing and revealing, also known as encrypting and decrypting, is carried out through a mechanism which involves some complex mathematics. One of the earliest forms of cryptographic methods is the Caesar cipher. That was used by Julius Caesar to protect Roman military secrets. In this method, each letter in a message was substituted with the letter that was 3 places to its left in alphabetical order. For example, if my original message were "This is cryptography," the encrypted message would appear as QEFP, FP, ZOV, MQLDOXMEV. The 3 places method is essentially the key to this cryptographic structure, also called as the cipher key. What are the types of cryptography? Broadly, there are 2 common forms of cryptography: symmetric and asymmetric. The previous example that we discussed is an example of symmetric key or symmetric cryptography. This method involves taking standard data and encrypting it using a mathematical algorithm which is called a cipher. The cipher produces a ciphertext, which is a piece of information that is nonsensical and utterly useless until it is decrypted. The second is public key cryptography, commonly known as asymmetric cryptography. It represents an improvement in symmetric cryptography as it allows for sharing of information through a public key that can be shared with anyone. However, instead of relying on a single shared key for encrypting and decrypting messages, a separate public key private key pair is used. The public key can be disseminated to everyone who wants to send you a message. The private key is kept secret, known only to yourself. Either of the keys can be used to encrypt a message. The opposite key from the key used to encrypt is used to decrypt the message. Also, a public key cannot be used to derive a private key or vice versa. Let us understand this with an example. Let's say Michael wants to send a message to his friend John informing him about his new venture. To send this message, he, that is Michael, encrypts the message with John's public key, available with him since John has sent it to all his friends. Once John receives the message, he will be able to decrypt it using his private key. Similarly, if John wants to send a message to Michael, he will encrypt it using Michael's public key and send it across. Michael will be able to see or decrypt it using his private key. What are the key differences then between symmetric and asymmetric cryptography? Symmetric cryptography uses a shared secret key for encryption and decryption, whereas the asymmetric cryptography uses a public-private key combination for encryption and decryption. Symmetric is simple and can be performed quickly, whereas the asymmetric is relatively sophisticated and takes more time than symmetric encryption to perform. Symmetric requires cipher or secret key to be shared privately between each pair of users, whereas asymmetric model eliminates the need to share keys privately. Public keys are available for everyone to use. Each time a new user is added to a symmetric network, it needs to establish a new secret key or cipher with each previous user. As in case of a symmetric network, for every new user, only a public key and private key pair is to be generated, with public key being broadcasted throughout the network for all users. Some of the modern approaches of symmetric encryption includes RC4, AES, DES, or Blowfish, whereas RSA, DSA, Diffie-Hellman are some of the popular forms of asymmetric encryption. Let's look at cryptography in blockchain. In blockchain, cryptography serves two primary purposes. First, safeguarding the identity of the sender of transactions. And second, ensuring that earlier records in the blockchain cannot be tampered or modified. Anyone using blockchain can have complete confidence in the security of the system. Once any information is recorded on the blockchain, it is done legitimately and securely. Public key or asymmetric cryptography is better suited to the functions associated with blockchain technology than symmetric cryptography. Let us understand how we implement cryptography while setting up our blockchain in JavaScript. JavaScript uses the CryptoJS library. It is a growing collection of secure, standard algorithms using best consistent practices and patterns. These algorithms are usually fast and have a consistent and simple interface. Some of the popular algorithms in the CryptoJS library are as follows. MD5. MD5 is a widely used hashing function. It is commonly used to check the integrity of files. However, it is not collision resistant and isn't suitable for SSL certificates or digital signatures, which are reliant on this property. SHA-1, also known as Secure Hash Algorithm 1, is the most established of the existing hash functions and was formulated by National Security Agency of US of America. SHA-2, also developed by NSA, includes significant changes from its predecessor SHA-1. It is essentially a family of algorithms consisting of 6 hash functions. The popular SHA-2 hash functions are SHA-224, SHA-256, SHA-384, SHA-512, or SHA-512/224 or 512/256. SHA-3 is the latest member of the SHA family of standards developed by NIST, National Institute of Science and Technology, USA. Although part of the same series, SHA-3 is internally very different from SHA-1 and SHA-2. It is a subset of the broader cryptographic primitive family KECAC. You can install a CryptoJS library with following simple steps. Invoke the terminal. Navigate to the folder where you have saved your blockchain JavaScript file. Install the CryptoJS library with the following code. You might see some warning messages displayed in the terminal window. Do not worry about those warnings, as they will not affect the context of this exercise.